This is part one of the implant modeling tutorial. I'm going to start off with a very simple, essentially a cylinder and some very basic anatomical features of an implant, and then we'll come back in part two and we'll actually model the threads and a little more complex modeling. We will not get into the internal connections. This is only the external part of the implant. For this tutorial, or for the second part of this tutorial, you will need the Bolt Factory add-on enabled. And I also have this plane here, which will come into play later. But for now, I'm just going to save this file as the implant modeler so that you don't have to bother making this plane. Okay, so first we want to familiarize ourselves with the implant we're trying to model. Here I have a few generic implants that I've mixed and matched some different diagrams to just kind of demonstrate. So I'm going to leave it as the responsibility of the user to find out the actual specifications of each implant. A few things to note is that the labeled length of an implant may not be its actual length. So it might be a 7.5, but in reality it's maybe 7.2. You also want to know where the manufacturer is referencing in these heights. Is it from here to here, or from here to here, or even from the bottom of the collar to here? For the particular one I'm going to model, the height will be the platform height, top of the collar to the apex. So some things you might be interested in. There we go. So for this particular tutorial, I've just made up some numbers here, and we'll have an external hex, non-tapered or parallel-sided implant that's approximately 10 millimeters. Notice it's actually 9.63. So let's get started. I'm going to hide this. I'm going to hide the plane. We're going to look at this from the side. And there are multiple ways to do this, but for now we'll just start with a circle. We'll tab into edit mode. And I'm going to let this be the apical cylinder, so we'll scale by 2.6 and then scale by 0.5. Now that's because when you add a circle, it gives you a radius of 1, not a diameter of 1. But all of our dimensions are in diameter. So I'm going to add another circle. Again, a radius of 1. So you can change this here, or you can scale it later. So just to show, I'll give this a radius of 2, or diameter of 4, which you may remember is our major diameter for this particular implant. And I'm going to hit G, hit Z to limit it to the Z axis and go 9.63. So that will take us all the way up here to the top of our implant collar. That's actually wrong. The implant collar is 4.1 millimeters, but I like to go up to the top, and now G, Z, minus 1. So that establishes the bottom section of our implant collar. So we're right here. If you want a bevel here and not a step, we could then move this down, G, Z, maybe a quarter of a millimeter. Oops. Negative quarter millimeter. Okay. So here we are again. The 3D cursor is still at 0, 0, 0. I'm going to add another circle. This time I'm going to make it 2.05. So that's 4.01 diameter. G, Z, 9.63. Oh, sorry, I have to be over here. G, Z 9.63. Shift D to duplicate those. G, Z, minus 1. So when I bring these down 1 millimeter, I have established the 1 millimeter height of the collar, and I've come down a quarter millimeter and established the major diameter of the implant. Now the final thing we might want to do, center our cursor, add a circle, 4 millimeters in diameter, and then while this implant is parallel-sided, it does taper here at the end. So we may want to just pull this up here to establish that taper. I don't know the what exactly it would be, but I'm going to guess 1 millimeter. Okay. So now we have all of our reference planes planned as a circle. Bridge these. A to deselect everything. Again. Looks good. Okay, if you didn't want this to be perfectly linear, you can select cubic, and you can play with this this factor here. I'm content with that for now. So now we have the basic shell, the body, and the collar planned. So I will come down here, and there's two ways to close this bottom. You can select this ring with loop select and simply fill. The problem is that kind of crisscrosses everything, and if we ever want to come back and gain access to the outer loop, it's very difficult. Notice if I hold Alt and select here, it no longer selects the ring. So I'm going to undo that. Show you a different trick. Make sure this is select on median. Extrude, scale, come in a little ways. Extrude, scale again, and hit 0. Now remove doubles, and that will merge all those points here. Now if we ever want to get back to this ring, we can either simply loop select it. Notice this loop will select as well, or we can select this one point and then delete these, and that will give us back to where we started. We'll use this trick again later. Right. So now I want to quickly make the external hex. I'm going to select the top layer here. I could also put the cursor location. If I deselect everything, I can put the cursor, where is it? I can place the cursor where I want manually. Alternatively, I can select all of these and Shift S, cursor just selected. It accomplishes the same thing, except it's a little less exact. So I'm going to add a circle. Now I'm going to select change in the redo panel here, 6. That establishes our hex. I just know from memory that our hex diameter is 2.7 tip to tip, which half of that is 1.35 for our radius. Hold Alt and Shift to loop select this and bridge that. We want to go linear, 0. Okay. So because we filled in the bottom here, I select the non-manifold edges, it will just select this hex here. If I had left the bottom open, it would select the ring down there. I'm going to hit E to extrude, Z to limit it to the Z-axis, and type 0.7 since that is the height of our hex. We're going to use the same trick to fill this hole. Extrude, scale, some arbitrary amount, extrude, scale 0, remove the doubles, and there you have it. Here's a basic shell for our implant. So I'm going to stop here because that's enough for now. And I know I moved through that very quickly, but you have the screencast, and you can definitely pause, and I'll try to add some annotations as well to help with following along.